Right, hi Year 12. So we're going to talk about the idea of internal resistance. Okay, so to start off, we'll talk about batteries. So we're going to talk about ideal batteries. So every battery we've kind of talked about so far, or every cell, we've assumed it only does one thing, which is provide an EMF to a circuit. Okay, that's the symbol for EMF. And we've said that that's it. That's all batteries do. So batteries don't add any resistance into a circuit. So provide an EMF and they have no resistance. Now in reality, batteries do have some resistance. So let's contrast this now with real batteries. And I'll do a kind of sketch of a real battery. There's the end part of the battery there. So all of these parts of the battery, the terminal of the battery at this end, of the terminal of the battery on the other end, they're made of metal, and those metal parts will have some resistance. There's also kind of within the battery, inside the battery are chemical reactions happening, charge is being separated, and kind of the effect of all that is there's gonna have some resistance. So real batteries do two jobs. They provide an EMF. They do two things. That's the job they do, but the second thing they do is that they also have some resistance. Okay, and the resistance of a battery is called the battery's internal resistance. The reason we say it's called the battery's internal resistance is because we often talk about the circuit resistance. So anything that's within the battery is internal, or to do with the battery is internal to the battery, whereas anything that's to do with the circuit the battery is connected to is external to the battery, so the external circuit. So the battery's own resistance is internal to the battery. So perhaps a better symbol for a battery would be this, because it provides an EMF and at the same time it's got some resistance. So I've just added a resistor symbol, and the battery's internal resistance is often given little r, the symbol little r, because the part of the battery that provides the EMF also adds some resistance into the circuit. Okay, so in reality, so the parts of the battery that provide the EMF can't be separated from the parts of the battery that have resistance. The battery is an entire thing, and it provides an EMF, and it also has some resistance. Okay. However, that is quite complicated, because how do you analyse this? Okay, it's got an EMF and it's got resistance as well, kind of all in the same thing. So what we've done as physicists is we've kind of created a model of batteries where we pretend we can separate out their resistance from the part of the battery that provides the EMF. Okay, so this is our scientific model. Our model for real batteries is this. That's the part of the battery that provides the EMF, and that's the part of the battery that has resistance. You can see we've separated out the two parts of the battery, but we've only kind of done that in our heads, because in reality a battery is one object. You can't separate those two things out. And then what we do is we draw a dashed line around those to show that all of this is within the battery, and this is our model. We've separated out the battery's resistance from the part of the battery that provides the EMF, because then we can deal with that. We can do circuit analysis on things which are separate. We can't do circuit analysis with this smush. Okay. So this is how we represent a real battery with internal resistance. Okay, so this little r is called the battery's internal resistance. So batteries add some resistance into a circuit. So if we then complete this circuit and connect an external circuit, I'll just pretend that wire's all joined up. So the external resistance in the circuit, whatever's connected into the circuit, it could be anything, could be in series, could be in parallel, whatever it's got a total resistance of capital R. What you might notice is that what we've effectively got in our model is a potential divider circuit, because we've got